All right, we've got section 8.3, factoring x squared plus bxc when c is positive. So our goal today, our objective, is to take a trinomial and factor it into two binomials. So our answer will look like this, two binomials. Maybe something like x plus 2, and then the other one maybe x plus 3. Since we're dealing with c is positive today, we only have two possibilities. They can be either two plus signs for the binomials, or they can be two minus signs. We're going to be using a new format called a Magic X Magic Box. So I go ahead and just make a standard nice X and a nice box here. And the way that I do it is I go ahead and find what is called my product. And my product is found from my x squared, whatever's in the front, times the c, whatever's in the back. So that is going to go on the top, x squared times c. Maybe it's x squared times 5 or x squared times 7, so on. My sum is going to be the middle of my trinomial here. So whatever's in the middle, in this case bx, that goes at the bottom. That is my sum. Once I've found that, I need to go ahead and find my two mystery numbers. And the way that we find our mystery numbers is as follows. I need to think about two numbers that would give me my product, so they have to multiply together to give me whatever's up here at the top. And then they would have to add together to give me my sum, whatever that may be. Once I have my two mystery numbers, I'm able to fill out my magic box. My x squared, that goes into my first box. And then my c goes to the last box. Whatever my two mystery numbers again, I put them in the two remaining boxes. So we've got our first trinomial here to try. So go ahead and set up your magic X and your magic box. Now remember, in order to find my product, I need to take my x squared and multiply it by whatever is at the back so that it's a nice 28. So my product at the top goes to be 28x squared. My sum, whatever's in the middle, is going to go at the bottom, so I've got my 16x. Now to find my two mystery numbers, some students may actually have to list them all out. Some people may be able to find it pretty quickly. Now remember, I need two numbers to multiply to give me 28 and add to give me 16. So if you need to list them out, it'd be something like 1, start with the 1 times 28. That definitely gives you the top, but not the bottom. So I need to try something else, maybe 2 times 14. 2 times 14 will give me 28, and when I add it together, it does give me 16. So I've got my two mystery numbers. I like putting the bigger number first, so that gives me 14x, and that gives me 2x. Once I've done that, I take the first part of my trinomial, x squared, and I put it in my first box. And then I take my 28 and I put it in my last box. Whatever I put at the front, my 14x, I like putting that at the top box. Now it doesn't really matter. You could put the 2x there if you wish. And then my last mystery number goes there. What I'm going to do now is some basic factoring, greatest common factoring like we've done before. So I'm going to ask myself the question, what can 14 and 28 both be divided or factored by? The question is not, what is 28 divided by 14? That would be incorrect. You must think about 14 and 28. Those can both be divided or factored by 14. I do the same thing to the bottom here now, 2 and 28. Those can both be divided by or factored by 2. Since I've got a nice x squared here, it's going to be pretty basic. X squared and 2x, they both have an x in common. And the same thing with x squared and 14x, they both have an x in common. Now to finish it off, I'm actually going to go ahead and do a little bit of mental math, a little mental check here like we did at the end of chapter 7. So I'm going to go ahead and do x times x. That does give me x squared. X times 14, that does give me 14x. That's why if you accidentally put a 2 up at the top, you would have gotten it wrong. 2 times x does give me 2x. and 2 times 14 does give me 28. So all of my factoring is done correctly. Now, if you look back at the original problem, you notice that everything is positive. So that means as I put my two binomials together, I need to make sure that I have two positive signs. So my answer is going to be x plus 14 times the quantity x plus 2. So our next problem is very similar. If you notice that they are two plus signs, again, that's really easy for us today. So I go ahead and set up my two items, my magic x and my magic box. I locate my product, which again is k squared times 20. And I locate my sum, 9k, so that goes at the bottom. I'm going to give you a little bit of time to see if you can figure out what the two mystery numbers are going to be. Remember, they need to multiply to give you 20 and add to give you 9. So you may have thought 1 times 20, that gives you the top but not the bottom. 2 times 10, it gives you the top but not the bottom. 3 is not going to work, but 4 times 5 gives us 20, and 4 plus 5 gives us 9. So I'm going to put my two mystery numbers as 5k and 4k. Again, I like putting the bigger one first. It doesn't really matter. I go to my magic box now. My k squared, again, goes to the first box. My 20 goes to the last box. Our two mystery numbers are going to go in the two remaining boxes. So I've got 5k at the top, and I like putting 4k at the bottom. I use my greatest common factor skills again. I ask myself, what can 5 and 20 both be divided or factored by? And that is going to be a nice 5. Same question, what can 4 and 20 both be divided or factored by? And that's going to be a nice 4. I've got a basic k squared, just similar to the x squared. So I'm going to put a nice k and a nice k. Now, some of you may have caught on already. You may be thinking, why do I need to do this whole box part when I think I can find my answer over here on the magic x? And the reason I'm asking you to do that is because later on we're going to be dealing with more complicated trinomials where you're actually going to have a coefficient greater than 1 in front of the k squared or x squared, where the box definitely is required. So we put our two binomials together. Again, I remember that everything is positive, so I'm going to go ahead and say k plus 5 times the quantity k plus 4. All right, so for this problem, a lot of students for some reason have some difficulty on, so let's see if you can do it. Let's set up our magic x in our magic box. We find our product again by multiplying the front of the trinomial by the back of the trinomial. And then our sum is the middle. And the most difficulty that occurs is from the actual mystery number. So I'll give you a little bit of time to see if you can figure out what the mystery numbers are. If you tried the suggestion that I made earlier about starting with the 1, you would recognize that 1 times 8 is 8, and 1 plus 8 is 9. So we've got our two mystery numbers. Again, I like putting the bigger number first. So we go to our box. Let's put our y squared in our first box, and our 8 in our last box. We've got our two mystery numbers. Now remember, for the greatest common factor, it is what can 8 and 8 both be divided or factored by? And that would be 8. Please do not say 8 divided by 8. Do not put a 1 up here. And then down at the bottom again, 1 and 8 can both be divided or factored by 1, or Juan. And then we've got a real y, or a simple y squared, so we've got a y and a y. For our quick mental math check, multiplication if you will, we got y times y is y squared. Y times 8 is 8y. 1 times y is Juan y. And 1 times 8 is 8. Since everything is positive again, I go ahead and put my two binomials. We've got y plus 8 times the quantity y plus 1. Finally, we have a problem here that is dealing with a negative sign. We're still going to start off the exact same way. So we've got our magic x and our magic box. Finding your product is the exact same thing. I've got x squared times 20, so we've got 20x squared. And then I've got negative 12x for my sum. Now the thing about the mystery numbers this time is when I do my multiplication, it's still going to give me 20, but notice how it's positive 20 while the sum is a negative 20. So that tells me that both factors are going to have to be negative, because I know that a negative times a negative is going to give me a positive 20. So I can start with the most basic again, negative 1, negative 20. That gives me the product, but it does not give me the sum. Then I go to negative 2 times negative 10. That does give me positive 20, and when I add them together, it does give me negative 12. So I do have my two mystery numbers. We fill out the box exactly the same way as example C, so I go ahead and put my x squared and I put my 20. For my 10x, I do remember it has to be negative, and with my 2x, it has to be negative. All right, so this is where it gets a little bit more tricky, dealing with our magic box, the greatest common factoring. I know that 10 and 20, those can both be divided by 10. So I need to put a 10 at the top, and I will talk about the negative sign in just a moment. 2 and 20, those can both be divided or factored by 2. I'll talk about the negative sign in just a moment. Nice basic x squared, so please just put an x times an x. So when I check it, the reason I have to put the negative sign is as follows. X times x is x squared. X times negative 10 is negative 10x. So in other words, if I put a positive 10 there, it would not be correct, because x times positive 10 would not have given me negative 10x. Negative 2 times x is a negative 2x. And then negative 2 times negative 10 is positive 20. I have my two binomials. Notice this time I have some minus signs. So I have x minus 10 times the quantity x minus 2. For the next example, it's almost exactly the same there. We have our magic x and our magic box. Notice that the sum is a negative again, so it's very similar to the previous example. I find my product and my sum. I'll give you a little bit of time to see if you can figure out what your mystery numbers are. Remember, the product is positive, but the sum is negative. Give you about 10 more seconds. Now, if you started off with the initial idea of negative 1 times negative 10, again, that works for the top, but does not work for the bottom, the sum. So I go to negative 2 times negative 5. That does give me positive 10, and when I add it, it does give me negative 7. So looking at the box, exactly the same way. Remember, I'm training you by using the box for when the problems get more complicated. You'll see that in a few days. So I got my x squared, my positive 10. I like putting negative 5x at the top and negative 2x at the bottom. My greatest common factoring, just like the previous example, I ask myself, what can 5 and 10 both be divided by? So I put a 5. Negative sign, we'll check again to see if they were accurate. I've got 2 and 10. Those can both be divided or factored by 2. Check the negative sign again. And then nice basic x squared, so I got x times x. We have x times x is x squared. x times negative 5 is negative 5x. Negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. So that shows me again that we were correct with our factoring in including a minus sign and a minus sign. You may be asking yourself, when do I use the minus sign? Do I have to use it always? Sometimes no. What is going on? We'll talk more about that in depth when we look at the other part of section 8.3. So your two binomials, if you haven't already created yet, are x minus 5 times the quantity x minus 2. Now, I haven't mentioned it yet, but if you were to put the x minus 2 in the front, it would still be a correct answer, as long as you have x minus 5 and x minus 2. All right, we've got our last example here. Exact same thing, so let's go ahead and create our magic x and our magic box. Our product we find really quick, really easy. Again, it's the n squared times the 5, so we get a nice 5n squared. And then our sum is negative 3n. I'm going to give you a little bit of time. Now remember, the product is 5 and the sum is negative 3. Now you may be getting a little confused here because 5 is a prime number, so that means only 1 and 5 would work. But remember, it'd have to be negative 1 and negative 5. Negative 1 times negative 5 does give us positive 5, but it does not give us negative 3 when I add them together. So the question is, if you've tried everything, and sometimes that is listing everything out on the side, but if you've tried everything and you cannot find the mystery numbers, again, you're not being lazy, you're not giving up too early, you've tried everything, but if nothing would work, our answer is going to be as follows. We're going to say it is prime. Occasionally, it may be not factorable, cannot be factored, but usually it is prime. Again, the other options are not factorable or cannot be factored. All right, so we finished off our first day of section 8.3. We'll continue on with the second day of 8.3 when we're dealing when C is negative, and we'll do that next time.